Hello everyone. Today we'll discuss homogeneous functions. Now, what is a homogeneous function? So it is a special type of functions in production economics. Generally, we frequently use it. The character of this function is that if the variables, independent variables of the functions are raised by a constant amount simultaneously, then output of the function will also be raised by the same amount. Suppose we have increased the inputs by 20% or 15%, then output will also be increased by 20% or 50%, same amount. This is the character. It is called monotonic transformation. It determines returns to scale explained by that particular function. So generally the degree of homogeneity is the returns to scale. So generally it happens in agriculture. Suppose we are going to produce a crop, we have applied inputs per hectare, we have recorded output. Then when we increase the inputs by some percentage, by some amount, say T or K, maybe 10% or 15%, and we record the new output, then we'll see that output has also increased by 10% or 15%. If 10%, output will also be increased by 10%. Now, the elasticities, some of the elasticities, it shows the returns to scale, but in homogeneous function, the degree of homogeneity is the returns to scale. So after the levels of the variables are raised by a constant, the value altered must be within the domain of the function f. The constant must be a positive number, so it should not be a negative. Suppose the production function is homogeneous of degree k. If tx1 and tx2, that means we have multiplied x1 and x2 by t factors, t amount, then it will be equal to t to the power k and function x1, x2. So k is the degree of homogeneity and k is the constant. T is any positive real number. So output is increased by factor t to the power k. K measures the returns to scale. So if k is greater than 1, it is increasing returns to scale. This means, suppose we have increased the inputs by 10%, output will be more than 10%. Then it is increasing returns to scale. So generally it happens at the very beginning of a production process, and so suppose we put less amount of inputs. Earlier we recorded or we obtained less amount of output, but later on we have seen that if we increase more amount of inputs, maybe that output will be more than that. If we increase, say 15% of the inputs, then output will be more than that. Then in that case, it is called increasing returns to scale. So in terms of homogeneity, k will be greater than 1. And if k is equal to 1, it is constant returns to scale. That means we are increasing 10% of the inputs, then we are obtaining 10% of the output. then k is less than 1. K is less than 1. That means decreasing returns to scale. So sometimes it also happens that suppose we have increased labor, land quality is also not so good, then increase labor. Because labor is not so productive, then the technology, suppose in agriculture, again say fertilizer or irrigation, that will be more effective than increasing labor. Anyway, if it is less than 1, then it is decreasing returns to scale. In production economics, homogeneity of degree 1 is commonly assumed. So generally we use functions which are homogeneous of degree 1. So there are some functions, I have given some illustrations. Suppose function, 2 variables, x and y, the function is x square minus y square. If x and y are increased by t times, then it is tx and ty is equal to tx square minus ty square. Okay? X square, because we'll have to multiply by t, so this is equal to t square x square minus t square y square. So if we take t square common, then it is t square into x square minus y square. So you see, we have come to this. So now this t to the power 2, so this 2 is the degree of homogeneity. So it is homogeneous. The function is homogeneous of degree 2. Degree 2. So it gives that increasing returns to scale. It will give it. If it is 1 constant, less than 1 is decreasing. Now another function, suppose this is the function x square plus x1 xy minus 3y square. So this is tx ty is equal to tx square plus tx ty minus 3 ty square. So if we simplify, we'll find that t square to x square plus xy minus ty square. So again, it is a homogeneous function of degree 2. So let us continue. A commonly used homogeneous function of degree 0 is x by z plus y by z. So it is the most commonly used homogeneous function of degree 0. Now if we multiply by t, so we have multiplied the function by t, so tx by tz plus ty by tz, okay, is the function of x, y, z. So if we cancel it, then it will be simply is the function of x, y, z, and we can put t to the power 0, because t to the power 0 is 1. Anything to the power 0 is 1, so there is no harm if we put t to the power 0. That means it is homogeneous of degree 0. Then another example, suppose the function xyz is equal to x square by yz plus y square by xz plus z square by xy. So this is the function. Now multiply the variables by t. So this is the total output, and if we multiply it, then tx square by ty tz plus ty square by tx tz plus tz square by tx ty. Okay. Now if we simplify and cancel, so I have put it in short, cancel, then it will be, because it will be t square x square, in the denominator it is ty tx, then it is t square yz, so t square will be cancelled like that. So x square by yz plus y square by xz plus z square by xy. So it will arrive at the same function, x, y, z. That means we can write t to the power z function x, y, z. Because t to the power z means 1. We can put 1 here. So it is, the function is homogeneous of degree 0. Now another function that we commonly use, it is a Cobb-Douglas function. So two economists, Cobb and Douglas, they developed this function. So this Cobb-Douglas function is homogeneous of degree 1. So earlier two functions are homogeneous of degree 0, but Cobb-Douglas function is homogeneous function of degree 1. So let us try to prove it. So let production is the function of labor and capital. Suppose two variables, independent variables, labor and capital. Now form of the function of Cobb-Douglas function is alpha L to the power beta and C to the power 1 minus beta. So L is labor, it is called power function. So L is labor and C is capital. Now P is production, then L is labor and C is capital. So P is the function of L and C, and this beta ranges between 0 and 1. So this is a restriction of the Cobb-Douglas function, that it should be 0 and 1. And the sum of the power, here it is beta, here it is 1 minus beta, sum of the power is 1. And in power function, the power is the elasticity itself. So in other functions, it is not, but in power function, the power is the elasticity itself. So sum of the elasticity is equal to 1. It is elastic. Okay. Now if we raise the levels of inputs by t times, then our function, main function is f, tl and tc. So function tl, tc is equal to alpha into tl to the power beta. We had L to the power beta, so it is tl to the power beta, and tc to the power 1 minus beta, c to the power 1 minus beta. So if we simplify, alpha t to the power beta, L to the power beta, again t to the power 1 minus beta, and c to the power 1 minus beta. So t to the power beta into t to the power 1 minus beta is equal to t to the power 1. So beta will be cancelled, t to the power 1. So alpha t to the power 1 and L to the power beta, c to the power 1 minus beta is equal to t to the power 1 is a function alpha L to the power beta, c to the power 1 minus beta. So it shows that the function is homogeneous of degree 1. Homogeneous of degree 1. So it will give the constant returns to scale. It means that if L and C are doubled in the production process, suppose L and C has been doubled, in that case output P will also be doubled. So this is the meaning, that homogeneous of degree 1 means if it is double, it will also be double. Or if it is triple, it is also be triple. we can also check the homogeneity of its marginal products. So this is the total product, homogeneity of the total product of products, the Cobb-Douglas function. We have seen it is homogeneous of degree 1. Now what is the homogeneity of the marginal products? So what is marginal product of a production function? This is the first derivative. So the first derivative is the marginal product with respect to labor. The first derivative, what is alpha, beta, L to the power beta minus 1, C to the power 1 minus beta. This is the first derivative. We have already got in the derivations. So first derivative with respect to L. Or we can write, for this we can write FL is equal to FL, LC is the function of labor and capital, is equal to alpha, beta, L to the power beta minus 1, C to the power 1 minus beta. Now raise labor and capital by T times. Now if we raise labor and capital by T times, FL is equal to FL TL and TC is equal to alpha beta TL to the power beta minus 1 and TC to the power 1 minus beta. So after simplification, so if we simplify this, it will be T to the power 0, a function LC. So we can do some homework. What will be the simplification of this? Alpha beta into TL to the power beta minus 1 and TC to the power 1 minus beta. What will be the marginal product? So it will be the T to the power 0 FL LC. So this means that marginal product is homogeneous of degree 0. So this shows that in Cobb-Douglas function, the main function, total function is homogeneous of degree 1, but if we increase the input, then marginal product will not rise, the T to the power 0. And this is ML, marginal product with respect to labor, is homogeneous of degree 0. When L and C are double, ML does not change. So similarly we can prove, or we can see the homogeneity of marginal product with respect to capital. So it will be 0. So this I have kept for homework. So thank you for observing. We will continue.